Welcome back, calculus students, and welcome to our fourth lecture in our lecture series on series. We are at our final tests of convergence, and that is the ratio test and the root test. Just as a quick review, what are the ones that we can do so far? Nth term's always first. We can check if it's a geometric series. We can do an integral test. We could check if it's a p-series, which came from the integral test. We could do some comparison tests. We could trap it with the DCT, or we could check a ratio with the LCT in our comparison tests. We could also see if there's some pattern of our sums. And finally, we could perform the ratio test or the root test. These are actually much easier than the limit comparison tests. First of all, the ratio test is basically kind of taking the series and treating it like a geometric series. So if we have a geometric series that is, let's say, 2 plus 1 plus a half plus a fourth plus dot dot dot, we can figure out what the ratio is by taking, let's say, the second term and dividing it by the first term. So if we did the second term divided by the first term, that's our ratio. That's our multiplier to get to each term. And we decided that if in the geometric series, if that ratio in absolute value is less than 1, then the series will converge. Well, what we're going to do with that, we're going to treat each series, and we're going to take the nth term and the term after the nth term. So if we had a sub n, then we'd do a sub n plus 1, and then we'd have a sub n plus 2. So what we're going to do is we're going to take these two terms, the a sub n and the a sub n plus 1, we're going to divide the n plus 1 term, this guy, by the term in front, and we're going to see what the ratio is. We call this rho. I don't know why that's the formal letter that's used, but we are going to check and see what that value is. And if that value is less than 1, then we are going to say the series converges. We're not going to have to worry about negative values, because remember, these terms are all positive. So if the series, if we compare the two terms and that ratio as the n goes to infinity gives us a value that is less than 1, the series will converge just like the geometric. If the value is greater than 1, the series will diverge just like the geometric one. If the value equals 1 in this case, nothing, we don't know anything, it's inconclusive. Okay? So that's the ratio test. And this works really well with factorials, if you have something factorial in there, and you'll see why in just a second. Okay, the last test, I'm going to show you the last test, and then we are going to look at a couple examples. So the root test is basically taking an nth term and raising it to the 1 over n power and seeing what you get. So if you take the nth root of an nth term, and if you end up with a value that is less than 1, the series converges. If you end up with a value that's greater than 1, the series diverges. And if you end up with a value that equals 1, that's inconclusive. You got to use a different test. Okay, this works really great when you have n in your exponent. Okay, before we do any practice problems on the ratio and root test, we just need to get a little algebra out of the way. So first of all, if you have something that looks like 5 to the n plus 1 over 5 to the n, you need to realize that's just 5 to the n times 5 over 5 to the n. And this cancels, and you end up with 5, which makes sense because you have one more 5 in the numerator, so you should simplify to 5. There's another thing we need to realize too algebraically. If I have 6 factorial, that's 6 times 5 times 4 times 3 times 2 times 1. Or we could say it's 6 times 5 factorial, right? Because this right here represents 5 factorial. Well, if I have n plus 1 factorial, I can think about it the same way I did here. That's the first term times, or the first multiplier times n factorial. Okay? So we need to keep those in mind when we go and simplify these things. When we're using the ratio and root test and we simplify. Okay, so what we're going to do here is take a look at, if you've printed out this worksheet, I'm just pulling a few from the practice problems, and I'm going to start with number 1. So to determine whether you want to use the ratio or the root test, you first have to figure out what's the best one. Remember, this ratio test works great for n factorial, and this works great if you have an nth power. The root test does. Well, I don't see factorial, but I do see an nth power here, so I'm going to apply the root test. So what I'm going to do is the limit as n goes to infinity of n squared over 2 to the n, and I'm going to raise it to the nth power and see what happens. Well, I can rewrite that as the limit as n goes to infinity of n to the 2 over n divided by 2. Okay, we have to go back and remember what is happening with this as n goes to infinity. And I've real quick put the work here to figure out that limit with L'Hopital's rule. Okay. I'll just let you stop the recording and kind of look through that and remember, if hopefully you recall that. So we end up with this, after we do the L and L stuff and we do the limit, we end up with this value of 0, but that's not what L equals, that's what ln L equals. So that equals 0, which means e to the 0 equals L, which means L equals 1. So what does that tell us? This guy up here, that's going to approach 1. So what does that tell me about this series? Well, this series is going, that using the nth or the root test, as I raise my nth term to the 1 over n, I'm going to end up with 1/2, which over here in the root test, if your value is less than 1, you know your series converges. And then we use the root test. Okay, next one. This is number 5 on the packet. So hey, here I see a factorial, so I'm going to use the ratio test. So we need to get our nth term, which is n factorial over 10 to the n. That's your nth term inside your sigma. I need to get my next term, which is a sub n plus 1. That's n plus 1 factorial over 10 to the n plus 1. Remember, with the ratio test, we're trying to figure out what the ratio of 2 consecutive terms is. So it's like taking the 5th term and dividing it by the 4th term, or taking the a to the n plus 1 term and dividing it by the term in front, which is a sub n. Well, that's going to give me a little bit of a mess to start with. Gives me that. And now I need to go ahead and multiply by the reciprocal of this. So when I multiply by the reciprocal, I get this, and then we have to think back to what we just simplified in a couple pages earlier. Remember, we said n plus 1 factorial over n factorial. That is just going to leave me with n plus 1. Where do we have more? Well, I have 10 to the n here. I have 10 to the n plus 1. So I have 1 extra 10 in the denominator. So what am I trying to figure out? A limit of n goes to infinity. N plus 1 over 10, well, that equals 0, which is, ooh, no it doesn't. I'm so sorry. That goes to infinity, which is definitely greater than 1. So we've shown this series diverges by the ratio test. What does that tell us? Well, that tells us pretty much that factorial trumps exponential. Factorial goes faster than exponential. Okay, next one I'm going to look at is number 8 on your extra practice problems in this worksheet. Well, I see a lot of nth powers here. So I'm going to go ahead and use the root test. I don't see any factorials. So I'm going to take this ln n to the n divided by n to the n, and I'm going to raise it to the 1 over n power. Well, that simplifies nicely. End up with ln n, because remember you're going to have n times 1 over n, which is just 1, and then n times 1 over n again. I end up with just n. What happens with that? Oh, that's infinity over infinity. Yay, I get to L'Hopital this thing. I love a L'Hopital. That just gives me 1 over n, which is 0, which is less than 1. What have I proven? I've proven this series converges by the root test. Okay, this next one is a bit crazy. I believe it was number 2 on your worksheet. I'm sorry, I don't have this number here. I'm going to go ahead. I'm going to go ahead and stop the video here and get a setup of it. We definitely know we're going to use ratio tests, but it just gets kind of messy. Okay, take a look at this setup. We know this is our nth term, what is in the sigma there. And we know this is our a sub n plus 1 term. How to get the 2n plus 2? Well, I just distributed the 2 to the n plus 1. Okay? Now, I did a sub n plus 1 over a sub n. And rather than writing this whole thing out twice, I just multiplied by the reciprocal of a sub n right here. Okay? All right, now we need to do a lot of cleaning up. First of all, 2n plus 2 factorial is 2n plus 2, and then we're going to bump it down one integer, 2n plus 1, and then it goes 2n minus 1, so then it's just 2n factorial, which is left. All over n plus 1 factorial times n plus 1 factorial. I'm sorry, I forgot to put the factorials on this. Times the reciprocal of a sub n, because we're dividing by a sub n. Okay. Well, let's rewrite this bottom part, kind of like we did the top. N plus 1 factorial is n plus 1 times n factorial. That's for one of them. And then we have another one. Oops. And now a bunch of stuff's going to cancel out. Eventually you're going to get to be able to do this in your head. You won't have to do all the work. Those cancel. Well, some of you won't. I know I can't simplify as quickly as many of you can, so I usually have to show more work than many of you need to. So now I'm looking at 2n plus 2, 2n plus 1, all over n plus 1 times n plus 1. I'm going to do the limit as n goes to infinity. Now what I'm going to do just to make this easier, I'm going to think about my highest degree term, which would come from here. That's 4n squared. It's not equivalent to that, so I'm not going to put an equal sign, but that's what you need to think about as your highest degree term, right? Because the other ones are insignificant, and n squared. And if we do L'Hopital on that thing over and over again, we're going to end up with 4, which is greater than 1. So what have we proven? We've proven this series that we started with. Ooh. This series diverges by the ratio test. Okay? That's all I'm going to go through for now. We'll do some more in class tomorrow. Have a great day.